Good morning, sir.
Good morning. Okay. So, at the last class, so what about the calculation? All calculation. ঠিক আছে সব?
ঠিক আছে।
ঠিক আছে না?
আর স্যার ওই যে ওইটার মড গুলো নিয়েছি তো আমরা।
হ্যাঁ মড। তো মড ভ্যালুটা ঠিক আছে?
হ্যাঁ।
Okay. Today we will start another design that is called high-pass filter design, and this is the design problem. It says that design a linear phase FIR filter using Hamming window and cutoff frequency omega c equal to 0.8 radian per sample and n equal to 7, and symmetry condition also not specified in this problem. Okay. So the point is, when this kind of problem is given, I said what are the things you have to note. We have to note few things, right? So what are the things you have to note? That is, what is the Hamming window function? This is written Hamming window. Therefore, Hamming window also not given in the problem. So Hamming window also you have to remember what is Hamming window. And cutoff frequency you have to note. Another thing you have to note, n equal to 7. Now, when no symmetric condition is specified, then you can assume any symmetric condition. But I have assumed h of n minus 1 minus n equal to hn. Right, this symmetric condition I have assumed. Okay, so no symmetric condition is specified. So you can assume any symmetric condition. Okay. Now, the next thing is you have to assume a desired filter response. Desired filter response for high pass filter, it will be h of e power minus j omega alpha. This is minus pi to omega minus omega c to pi. Is it all right, or you require explanation for this?
Yes.
For high pass filter? High pass filter, is it okay?
Yes.
Very good. So for high pass filter, your pass band will be minus pi to minus omega c or omega c to pi. This is your pass band, and it will be 0 otherwise. So this is the desired filter response. Anybody having doubt in this other than those who have understood? Anybody did not understood this? Everybody understood this? This step, for any high pass filter design, this step will be the same. Any high pass filter design, FIR filter design with linear phase, this step will be same for any FIR filter high pass. So this step will be same. Now, our hd of n 1 by 2 pi minus pi to pi hd of e power j omega and d omega. Then it will be minus pi to pi, and 1 by 2 pi ta hobe, ঠিক আছে? So this will be also 1 by 2 pi. So minus pi to pi e power j omega and minus e power minus j omega alpha. Next step I can write 1 by 2 pi minus pi to pi e power minus j omega n minus alpha. All right, this step.
Yes, sir.
Now, what I am writing, this is 1 by 2 pi minus pi to omega c and 1 by 2 pi omega c to pi. Right, as per this notation, only in this region I have to integrate. Okay, so rest of the region the value is 0. Okay, so I will integrate this 1 by 2 pi minus pi to minus omega c e power minus j omega n minus alpha d omega, and 1 by 2 pi omega c to pi e power j omega n minus alpha d omega. Now if we integrate this, it will be e power j omega n minus alpha and j times n minus alpha minus pi to minus omega c. And this is 1 by 2 pi e power j omega n minus alpha by j times n minus alpha omega c to pi. Now, if I take this, if I substitute minus omega c, so you got j omega minus omega c n minus alpha, j times n minus alpha, minus of e to the power minus j pi times n minus alpha, j times n minus alpha. Okay. Then for this one, it will be 1 by 2 pi e to the power j pi n minus alpha by j times n minus alpha minus e power j omega c n minus alpha j minus alpha. Then if you simplify this further, then I have taken 2j inside and pi times n minus alpha. This is one section. So what I have done, I have written e power j times pi minus alpha, this term, minus this term. Pi times n minus alpha I have taken out, and I have taken 2j here. Similarly, the e power j omega n minus alpha with the minus sign, so I have taken minus common, and e to the power minus j omega c n minus alpha, this is plus sign, so minus minus of this. Then if you simplify, it will be 1 by pi times n minus alpha, sine of pi times n minus alpha, sine of omega c n minus alpha. This is valid for all values of n except n equal to alpha. If I put n equal to alpha, this becomes 0, this becomes 0. If n equal to alpha, this equal to 0. So it is 0 by 0. If it is 0 by 0, in such a case, for that particular thing, it will not valid. In such a case, you have to apply L'Hospital rule. Then what I am assume for n equal to alpha, this is undefined. Therefore, what we will do, we will assume n minus alpha. So this becomes pi times n into u, n minus alpha equal to, and n tends to alpha, u tends to 0. So therefore, sine u times pi minus sine omega c u by pi times u. Then if you find the 0 by 0 means you have to derivative, find the derivative and you have to find the derivative. So this derivative will give you pi times cos pi u minus cos omega c u multiplied by omega c, and this is pi times 1. Derivative of u becomes 1. Now you have to substitute u equal to 0. If u equal to 0, that is pi minus omega c, because this is u equal to 0. So this becomes 1. And u equal to 0, this becomes 1. So this is pi minus omega c by pi, which is equal to 1 minus omega c by pi. So for n equal to alpha, hg of n, that will be equal to 1 minus omega c by pi. Is it all right? Is it all right?
Yes, sir.
Yes, sir.
Very good.
Okay.
So for all values of n, for all values n except n equal to alpha, this is the equation. And for n equal to alpha, this is the equation. Now Hamming window. What is Hamming window? Hamming window is defined as, instead of rectangular window, this has become 1. And this window definition is 0.54 minus 0.46 cos 2 pi n n minus 1. This is the definition of this window over the limit n equal to 0 to n minus 1. That's the n
Why
equal to,
Darsana?
huh?
Why Darsana, sir?
That's n equal to 0 to n.
Sorry.
Phone is nahi?
हाँ sir, पापार phone टा छिलो, sorry.
हाँ, take it. No, not an issue. So n 0 to n minus 1. So WH of n, that is equal to 0.54 minus 0.4. This is the definition of Hamming window, right? That over the limit 0 to n minus 1, this is the value 0.54 minus 0.46 cos 2 pi n by n minus 1 over this value, and otherwise this is 0. So instead of 1, you have to assume this value, right? So what particular window will be given? So in your syllabus, I think 2-3 windows are there. I will discuss all 2-3 window. That only you have to study, right? This window function is used instead of rectangular one, right? Okay, so if you want to make it finite now, this is an infinite response, ht of n. Then you have to make it finite. Then hn equal to hd of n into w of n. So hd of n equal to this when n is not equal to alpha. So this I have written hd of n, and whn as it is I have written. So this will be entire expression of hd of n for n is not equal to alpha. Similarly, for n equal to alpha, hd of n equal to 1 minus omega c by pi, hd of n. So I will substitute that, and same window for n equal to alpha. Then you are having two equations of hn, that is impulse response. Okay. Now, for n equal to 7 samples it is given, and omega c equal to 0.5 radian per sample. This is the digital cutoff frequency of high pass filter. Now alpha equal to n minus 1 by 2. This is equal to 6 by 2 equal to 3, and n minus 1 equal to 6. Okay. So if n minus 1 equal to 6, that means you are having the limit of impulse response or impulse response that will be 0 to 6. 0 to 6, because limit of non-zero impulse response for a FIR filter will be n equal to 0 to n minus 1. 0 to n minus 1 means n equal to 7. So 7 minus 1 equal to 6. So it will be 0 to 6. 0 to 6. So if n equal to 0 to 6, then you have to find up to h6. Now, if I assume the symmetric condition h of n minus 1 minus n equal to hn, then h of 6 minus n equal to hn. Therefore, if I put n equal to 0, it becomes h6, h6 equal to h0, h5 equal to h1, n equal to 1, and for n equal to 2, h4 equal to h2. I think you understood this. This is the symmetric condition I have applied. And h3 equal to h3, so I have not written. So what I am saying that h0, h1, h2 if you obtain, and h3 for another equation, like h3 using equation, right, n equal to alpha. For n equal to alpha, this is the equation. And alpha equal to 3. Alpha equal to 3 means for h3, you have to use this equation. And not equal to 3, any other value means 0, 1, 2, 4, 5, 6. You have to use this equation. These are the two equations you have to use. Now, one more thing that h0, h1, h2, if you calculate, then you can calculate h4, h5, h6. So essentially, you have to calculate h0, h1, h2, and h3. If you calculate these four values, all filter coefficients, like 7 filter coefficients, are obtained. Now, another important thing at this stage, in this expression, if you look at this expression, now we have estimated alpha equal to 3, and if n is also integer and alpha is obtained as integer, then sine of n minus alpha, this is a difference also will be integer, and sine pi n this is equal to 0. Agreed?
Yes.
So if this is equal to 0, then it expression becomes hn equal to sine omega c. This expression becomes sine omega c, and n equal to, we have to obtain alpha equal to 3. So this becomes omega c n minus 3, and this is pi times n minus 3 because alpha equal to 3. Then this window function is, in window function also there is a modification, which is cos 2 pi n by n minus 1. If n equal to 6, n equal to 7, so 7 minus 1 equal to 6. So 2 by 6 means 1 by 3. So this becomes pi n by 3. Agreed? And this is the equation for n not equal to 3. N not equal to 3. That is n not equal to alpha. And n equal to alpha, this is the equation. Same modification in this function will be same because here n minus 1 is substituted. And this becomes 0.46 plus pi by n. And for n equal to 3, this was the expression like 1 minus omega c by pi. Then I will write 1 minus omega c by pi and this expression for n equal to 3. Agreed? So thereby, ultimately, we are having two expressions, hn equal to n not equal to 3 and hn equal to 3, n equal to 3. Now you substitute, say, n equal to 0. If I substitute n equal to 0, then I will get h0 equal to minus sine 0.850 minus 3, because omega c equal to 0.85 radians per sample. So distal cutoff frequency. So I have to substitute here, and n equal to 0. So 0 minus 3, and this term will substitute, and this is pi times 0 minus 3 because n equal to 0. If you calculate, you will get minus 0.0081. Okay. Similarly, if I substitute n equal to 1, then h1 equal to minus sign of this. So I substitute n equal to 1 and n equal to 1 here. Then if we simplify again n equal to 1 here, so it will cos pi by 3. So if we simplify this thing, you will get something like that, 0.0469. Now, if you look at h2, it becomes minus sine 0.85, 2 minus 3. So n equal to 2, 2 minus 3 is 2 minus 3, pi of 2 minus 3, 0.54, and this is like that. So it will minus 0.141441. Now for h3, we have to use this equation. So I have to use this equation. So 1 minus omega c by pi, 0.8 pi is the cutoff frequency, by pi 0.4, and then we have to use 3 pi by 3 because n equal to 3. So this becomes 0.2. Okay. Now H4 equal to H2, H4 equal to H2 with a negative sign. Okay, and H5 equal to H1. This is the value because H1 is already calculated, so I have written here. And H6 equal to H0. H0 is already calculated, so we have estimated H6. So like that, we have estimated H0, H1, H2, H3, H4, H5, H6. All values are estimated. Now, if you find the frequency response was the value magnitude h of e power j omega, magnitude h of n minus 1 by 2 plus n equal to 1 to n minus 1 by 2, 2 times h n minus 1 by 2 minus n into cos omega. This is we have derived. This is what we have derived for symmetric impulse response with symmetric condition h of n minus 1 minus n equal to hn, and for odd number of samples. This we have derived already. So we'll directly use this expression. So h3, so n minus 1 by 2, so n equal to 7, 7 minus 1 by 2 means h3. Then you will write n equal to 1 to 3, 2 times h, so n minus 1 by 2 equal to 3. So I will write 3 minus n and cos omega. Okay, so that I am writing. Now, if I substitute n equal to 1, n equal to 1 means 2h2 cos omega. And if I substitute n equal to 2, then it will be 2h1 cos omega, cos 2 omega. And if I substitute n equal to 3, then it will be 2h0 cos 3 omega. So this will become magnitude h3 plus 2h2 cos omega, 2h1 cos 2 omega, and 2h0 cos 3 omega. Now again, I have said in the last class, if you take the coefficient, this index 2 and coefficient of omega, this becomes 3. This is 1 and this coefficient is 2, this becomes 3. This is 0, this is 3, so this becomes 0 plus 3. Now, if I substitute this value 0.2, 2h2, h2 to have this one the value 2h2, so this becomes minus 0.2882 cos omega. Then this becomes 0.0938 cos 2 omega, and this becomes 0. Because actually what I have done, I have substituted h2, h1, and h0 and multiplied by 2. Okay, so I have substituted. So up to this, I have computed the frequency response, expression for frequency response. Okay, so any doubt if you have so far? Any doubt?
Hamming window এখানটা একবার বলতে হবে এখানটা আমি শুনি
Hamming window means a different window function. So regarding this window, all windows are having same function. Function is to convert the infinite impulse response hd of n into a finite one. This is the purpose of any window. Now, any kind of window that is given, only this is the expression. Instead of 1, you are having only this expression. And this is valid for n equal to 0 to n1. Different expression for different kind of windows. In your syllabus, 2 to 3 windows are there. I will discuss all these 3 windows on problem. So only thing is that window function is nothing but a quantity that is to be multiplied with the hd of n, so that it is a finite and ranging from 0 to n minus 1. This window is a specified window, and this will be given in the problem, or if it is not given, then you have to remember this also. Okay, so for this, you have to remember this also. So which is not this difficult expression, 0.54 minus 0.46 cos 2 pi n minus 4 minus 1. That you can always remember. At least if you remember first digit 0.54, then 1 minus that will be 0.46, right? That cos 2 pi n by n minus 1. Like that also you can remember. But anyway, this expression you generally have to remember, because I have seen many problems where Hamming window is written, Hanning window is written. So in such a case, window function is not given. So it is assumed that you have to remember that. Okay. So this window function is given means you have to multiply with this window. Whatever window function is, don't need to bother much. You have to multiply with this. Now a question may arise, then why different kind of window function instead of single window function? That actually you have to you can understand only if you do the practical of this, right? If you have MATLAB programming, then if I use different window function, what is the effect of using different window function, that you can understand. That I cannot draw in pen and paper. What is the difference? I can tell you what is the difference. Difference is, in filter you are having pass band and stop band because you are designing the practical filter. In practical filter is not the ideal one. Ideal, what is the difference? Difference is, in ideal filter, cutoff is sharp. For example, if we are talking about high pass filter, then immediately after omega c, your pass band is constant, and immediately before omega c, your pass band is 0. Such kind of thing is not possible in practical design, I said. That such a sharp cutoff you cannot have. So essentially, you are having a gradual rising from stop band to pass band, or pass band to stop band, gradual rising, not sharp. Now this gradual, but however, which one is better? When the, if the cutoff is sharp, this is most better. Therefore, in different kind of window, it is observed that different kind of slope is observed in passband to stop band transition or stop band to passband transition. If I talk of high pass filter, means your passband is high pass. If I talk about low pass filter, means low pass is the passband. Other than this low pass, if I talking about low pass filter, that is your stop band. Therefore, passband to stop band transition or stop band to passband transition, this transition as fast as you can achieve, that is better the design. Therefore, different window technique that is used to repair this passband or achieve the ideal characteristics in the passband to stop band transition, near ideal as I can reach. So that the techniques are different window techniques. So that can only be understood if I design a same filter using different technique and then plot the response in MATLAB. Then you will see that transition will be different for different kind of window technique. So essentially, different window technique that ensure different kind of passband to stop band transition. Again, this is also application specific. In some application, because passband to top band transition, if I want to improve this, what I have to do, I have to use complex hardware. At the same time, we have to use complex mathematical expressions. Like Hamming window, this expression is complex. If I look for Blackman window or other windows, they are having even complex expression. But essentially, it requires more hardware. And then why it is used? Because some application it is desired that passband stop band, this transition has to be very fast, very fast. Even not possible to you reach the ideal, but we can reach better and better in different kind of windows. Agreed? What is the purpose of using different kind of window? Agreed? So if the
Yes.
question is asked that what if the question, what is the purpose of different kind of window, this question may ask in Viva as well as your 1 marks or 2 marks question in 3 or 3 plus 5 marks question 2 plus 3 there will be asked. So different kind of window ensures different kind of passband to stop band transitions. It is desired that passband to stop band transition or stop band to passband transition that could be as close to the ideal characteristics. Therefore, different kind of windows are used to ensure the different passband stop band characteristics depending on particular application. I hope this is agreed, understood. Okay,
Yes, sir.
very good. Now, if I have any scope in laboratory, then definitely I will show you that different kind of window, how could you have different kind of passband stop band characteristics. Okay. Now, if I have now h of e power j omega, so h of e power j omega, then you are having this expression. Now, you substitute, if I see omega equal to 0, omega equal to pi by 8, 2 pi by 8, I have said that you can take more number of points, but in practically when you're solving a problem in examination, taking more number of points will be difficult because you have to manage the thing within a limited time. So in my suggestion, 0, pi by 8, 2 pi by 8, 3 pi by 8, 4 pi by 8. So it is a multiple of pi by 8 I am taking. So 0 into pi by 8 equal to 0, 1 into pi by 8, 2 into pi by 8, 3 into pi by 8, 4 into pi by 8, 5 into pi by 8, 6 into pi by 8, 7 into pi by 8, 8 into pi by 8. And I have said that for practical design, we'll only consider 0 to pi. 0 to pi is my design, practical design target, not the negative frequency, only positive frequency. Negative frequency and whatever they are up to the theory. But when you are having the practical design, it will be only 0 to pi. I will design for high pass filter. Now, if you look at this data distribution, then you will see this data is very small in amount, 0.01, 0.00, 0. Like that, very small in amount. And this is 0.1, then this is see gradual increase of the data. So 0, 0 to 0.3, so this is constant, this is decreased, this is increased, this is increased, this is increased, this value is also increased, 0.2, 0.2 is more than 0.1, 0.3 is more than 0.2, and 0.5 is more than 0.3. Like that, this value is gradually increasing. So from the given data, also I have understood, yes, it is a high pass filter. Now, while plotting the data in examination, first we have to see what we have calculated. This is look like a high pass filter type or not. Because after while plotting, if you understand this is wrong, then you have to come back to here. But while calculating each value, after 2-3 value, while designing high pass filter, in your mind that is the for omega c to pi, this value will be 1, or there should be pass band. Therefore, you have to understand that from 0 to, if I assume from omega c to pi, in that region, what I'm expecting my filter response should rise, because for high pass filter, what I'm expecting that it should pass band will be omega c to pi, so greater than omega c. So as I am moving from 0 to pi, my response should be gradually increasing for high pass filter. And low pass filter, just opposite. So if we move from 0 to pi, so in that region, your value has to be gradually decreasing. So this is the two difference between high pass filter and low pass filter. Agreed?
Yes, sir.
So therefore, while tabulating the data from the frequency response characteristics, what essentially I am doing, I am tabulating the data from the frequency response characteristics in order to plot the response of the filter. So while looking at the data itself, I can understand whether my design is correct or not. Right? So after getting this data, you have to plot this data. Now, while plotting also, your this scale is fixed 0 pi by 8, 2 pi by 8, 3 pi by 8, 4 pi by 8, 5 pi by 8, 6 pi by 8, 7 pi by 8, and pi. This scale is fixed. However, this value is a different nature for different kind of filter design and different kind of filter problem. Also, different kind of window function. In this case, your this particular axis, y-axis, you have to choose very carefully. Now see here, maximum value is 0.5, right? 59 or 0.6, something like that. So I will take the y-axis 0, and next 10 small division I will take 0.05. Understood? So 10 small division I am taking.
सर एग्जाम में की ग्राफ पेपर है आपके?
अच्छा कोई नहीं खड़ा। हेलो, হ্যাঁ বলো।
হ্যাঁ স্যার, বলছি স্যার এক্সামে যখন করতে হবে গ্রাফ পেপার দেয়নি?
হ্যাঁ, গ্রাফ পেপার দেবে, গ্রাফ পেপার। সো এক্সামে গ্রাফ পেপার মানে তোমার কোন গ্রাফ পেপার? যেটা ওই নর্মাল যে গ্রাফ পেপার সেটা, বুঝতে পেরেছো? যেটাতে মিলিমিটার। সো এক্স ওয়াই স্কেলে যেখানে ড্র করা যাবে, লগারিদম না, নট লগারিদম. So what you have to do, you have to take 10 division 0.05 I am taking, next 10 division 0.1, next 10 division 0.15, next 10 division 0.2, next 10 division 0.25, next 10 division 0.3, next 10 division 0.35, next 10 division 0.4. So 10 small division I am taking 0.05. Agreed? 10 small division I will take 0.05 along this axis. Because this, why I am doing this, then plot will be better and better. such to selection, because if I am value 1, then last class I have taken 0.1, 0.2 up to 0.1 to 1. Your maximum value was 1, 1 to gradually decreasing. So 1 was the maximum value. Now it is from 0.0 to 0.6. So I have taken this kind of distribution. Now this axis it is 0, pi by 8, 2 pi by 8, 3 pi by 8, 4 pi by 8, 5 pi by 8, 6 pi by 8, 7 pi by 8, 8 pi by 8 means pi. So these are the values here. Now once I have this, what I have to do? Pi by 8 I have to plot value, put the value. So pi by 8, what is the value? 0.01. So 0.01 means 0.01 pi by 8 কত? 0 0 তে 0 তে হ্যাঁ 0 0 তে 0.01 0.01 মানে হলো একটা ছোট্ট 1 ডিভিশন। এই পুরোটা যদি 10টা ডিভিশন হয় আর একটু নিচে হতো, তোমরা তো পরীক্ষায় তো ওটা দেখে করতে হবে। 0.01 মানে এই স্কেলটার একটা ডিভিশন, তাই না? 10টা ডিভিশনের মধ্যে একটা ডিভিশন নিতে হবে। তারপরেরটা কি? তারপরেরটা 0.00, আরো কম, অলমোস্ট 0 0 0। তার মানে এটাকে আমি প্রায় কি করেছি, লাইনের উপরে নিয়ে চলে এসেছি প্রায় অলমোস্ট 0। তারপর 2 পাই বাই 8 এর কত ভ্যালু? 2 পাই বাই 8 এর ভ্যালু হচ্ছে গিয়ে 0.00, অলমোস্ট 0। সো 2 পাই বাই 8 কে অলমোস্ট লাইনের উপরে নিয়ে চলে এসেছি। 3 পাই বাই 8 এর ক্ষেত্রে ভ্যালু কত? 3 পাই বাই 8 এর ভ্যালু 0.3। 0.3 মানে হলো কি 8, 0.5 হচ্ছে পুরোটা। তার মানে 0.3 মানে এই মাঝামাঝি কোথায় আর হবে, এই জায়গাটা করে হবে। তাহলে এখানে পয়েন্টটা দিয়েছি। 4 পাই বাই 8 টা কত? 4 পাই বাই 8 মানে যেটা পাই বাই 2 0.1 এর কাছাকাছি। 0.1 এর কাছাকাছি মানে আমি ধরেছি 0.1 এর কাছাকাছি এটা পয়েন্ট 4 পাই বাই 8, তাহলে এখানে চলে এলো। 5 পাই বাই 8 টা হচ্ছে দেখো 0.2 এর থেকেও বেশি। 5 পাই বাই 8 এর ভ্যালুটা কত? 0.22। তাহলে 0.22 মানে হচ্ছে 0.2 টা আমার এখানে আর, তো 0.22 টা এখানে কোথাও একটা আসবে, তাহলে আমি এখানে নিয়েছি এটা। ঠিক আছে? মানে তোমরা গ্রাফে যখন প্লট করবে ইউ ক্যান ডু ইভেন বেটার অ্যাপ্রক্সিমেশন, মানে আরো বেটার এটা ড্র করতে পারবে। সো 6 পাই বাই 8 সামথিং অ্যারাউন্ড এখানে, 7 পাই বাই 8 টা এখানে, 8 পাই বাই 8 টা হচ্ছে 0.5 এর কাছাকাছি। তার মানে কি এখানে দেখো রেসপন্সটা কি হলো, লো ফ্রিকোয়েন্সি থেকে হাই ফ্রিকোয়েন্সির দিকে পাস ব্যান্ড যাচ্ছে। তাহলে দিস ইজ এ ডিজাইন এক্সাম্পল অফ এ পাস ব্যান্ড ফিল্টার। অ্যানাদার ইম্পর্টেন্ট থিং, নাও সি এখানে 4 পাই বাই 8, 5 পাই বাই 8 এখানে গ্রাফটা ড্র করা একটু কঠিন হচ্ছে। কারণ কি এখানে মাঝে আরো পয়েন্ট দরকার ছিল, তাই না? মাঝে আরো পয়েন্ট দরকার ছিল। সেই কারণে এই গ্রাফটা ইফ ইউ ক্যান প্লট উইথ say pi by 16 multiple, then every between 0 0 to pi by 8 you can have one more value. So pi by 8 to 2 pi by 8 you are having one more value. 2 pi by 8 to 3 pi by 8 you are having one more value. 4 pi by 3 pi by 8 you can having one more value. So if I take the multiple of pi by 16, then this will be your pi by 16, this will be your 2 pi by 16, this will be 3 pi by 16, this will be 4 pi by 16, like that. If in an interval of pi by 16, everywhere you will be having one more value in between. ঠিক আছে? Everywhere you will be having one more value in between. So 0 to pi by 8 you are having one value, and if we take one more value in between, then your response will be much better and better. Agreed? Okay. So if you have any doubt you can ask, otherwise I would like to close for today. Okay, do you have any doubt?
No sir.
Everything is all right?
ফেজটা কি করে বার করব?
ফেজ এইটার ফিল্টারের ফেজটা বার করতে হবে না। বার করতে হবে না মানে ফেজটা ড্র করতে হবে না। ফিল্টারের ফেজটা বার করবো কি করে, সেটা তো বার করেছি থিওরিটিক্যাল আলফা ইকুয়াল টু n - 1/2 = 3। আলফা ইকুয়াল টু n - 1/2 = 3, সেটা হচ্ছে কি ফেজটা। সো দিস ইজ দ্য ফেজ আলফা ইকুয়াল টু n - 1/2/3। সো দিস ইজ দি ফেজ। এবার বলছো ফেজটা প্লট আমি কেন করছি না? ফেজটা আমি কেন প্লট করছি না, তার কারণ হলো যে ফেজটা ফিল্টার রেসপন্সকে, দুটো ফিল্টার রেসপন্সকে আলাদা করবে না। লো পাস ফিল্টার and high pass filter, that differentiation is made by the means of magnitude response, right? Magnitude response. What is the phase here? The phase here is 3 omega, because alpha equal to 3, phase equal to -3 omega. Is not it? Is it okay?
Yes, sir.
So if alpha equal to 3, phase equal to -3 omega. If I design for n equal to 7 low pass filter, that phase is also -3 omega. Because e to the power minus jn - 1 into omega corresponding to the symmetry condition h of n equal to h of n minus 1 minus n. Corresponding to this symmetry condition h of n equal to h of n minus 1 minus n, your phase is e to the power j omega n minus 1 by 2. Therefore, this phase omega n minus 1 by 2, that is dependent on what kind of symmetry condition I am choosing. And that will remain same for high pass filter and low pass filter, another filter as well. So phase is not the factor which distinguishing different kind of filter response. What is distinguishing different kind of filter response? This is the magnitude response. Therefore, I will plot only magnitude response. Phase response I need not plot. However, if I want to plot, I can always plot different values of omega, that is pi by 2, whatever there. You have to plot just 3 or minus 3 omega, right? But phase response, that does not distinguish different kind of filter response, so you need not plot the phase response. But however, you can plot a similar way. Only thing, you have to calculate the value of minus 3 omega, and you have to take different values of omega. You have to calculate minus 3 omega and plot this. That will be the phase response. But phase response is not required because the different kind of filter, low pass, high pass, or band pass or band stop filter, they can have same phase characteristics, because this is dependent on the kind of symmetry condition that you choose, and also what is the center of symmetry. Agreed? So phase, as far as phase is concerned, that is not an important parameter for plotting or understanding the signal. However, phase linearization is required. Phase linearization is required to remove the phase distortion or to eliminate the phase distortion. All right. So any doubt if you have, you can ask. Otherwise, I would like to stop today. I hope this is completed for today's class. If you have any doubt, you can ask.
No, sir.
No doubt. Now I am asking you one question. Can you design any linear phase FIR filter, high pass or low pass, for different values of n, different number of sample values, different number of cutoff frequency? So you should be in a position to design any low pass high pass filter for a given symmetry condition, and also for different values of n. Can you do that? अभी तक जितना हुआ করতে পারবে, তাই তো? So next I will discuss band pass filter and band stop filter one example, and two different window also, and then I will conclude next week maybe with two classes. Then I have one more topic left, that is called IR filter design. With that, most of the part of your course, 95% will be complete. So again we will meet next week. Okay?
স্যার আগের দিন এটা থেকে একটা প্রবলেম ছিল।
কি বলেন বলো?
স্যার আগের ওই পিডিএফটাতে একটা জায়গায় ছিল n equals to 3 দিয়ে করলে আমরা এখন করছি ওটা 0 আসছে, কিন্তু ওখানে আপনার 0.2 পাই বাই কিছু একটা ছিল।
তাই সেটা পরের দিন বলবে।
আলাদা একটা রুল ছিল, আপনি বলেছিলেন কিন্তু বুঝতে পারছি না।
ও বুঝতে পারছো, ঠিক একটা পরের দিন মনে করবো, আজকে সময় নেই, 1 মিনিট আছে, একটু আগে বললে করে দিতাম। ঠিক আছে, পরের দিন তাহলে ওটা আমি একটু বলে দেবো, তোমরা কোন জায়গাটা পরের দিন মনে করবে। ঠিক আছে, এখন আর 1 মিনিট আছে, তো আগের দিনে নোটে তো দেখছি, দেওয়ার চেষ্টা করে, যদি হয়ে যায় তো ভালো, আর না হলে কালকে বলে দেবো। আগের দিন দাঁড়াও দেখে নিয়ে নেবো, তারপরে যদি হয়ে যায়।
থ্যাংক ইউ স্যার।
দাঁড়া 1 মিনিট দাঁড়াও, যদি সময় পাই একটু 1 মিনিট আছে মনে হচ্ছে, যদি দেখিয়ে দিতে পারি। যদি হয়ে যাচ্ছে তো করে দিচ্ছি। কোন জায়গায় আছে বলো তো ওটা?
পেজ নাম্বার 3 তে।
পেজ নাম্বার 3 তে
n equals to 3 দিয়ে আছে যেটা।
n equals to 3, হ্যাঁ এটা এখানে কোথায়? পেজ নাম্বার 3 এইটা n equal to 3 এইটা।
হ্যাঁ
h1 h2 h3, হ্যাঁ এটা ঠিক, ওমেগা c বাই পাই তো। h3 equal to omega c by pi for n equal to alpha। এই যে করেছি এখানে দেখো, এই যে h3 equal to omega c by pi করিনি, এই যে omega c by pi for n equal to alpha, n equal to 3, this is omega c equal to omega c by pi, so omega c equal to 0.2 ওটা ছিল, তাহলে সেটা বসিয়ে দিয়েছি এখানে, বুঝা গেল? এই যে omega c by pi, omega c equal to 0.2 pi by pi, that is equal to 0.2। Okay, because alpha equal to 3 na, alpha equal to 3,
So
n equal
3
to alpha.
minus 3 equal to 0.